First, allow me to apologize. Probably some of you have already confused. That guy does not look like a Ahmed. No, I'm not in the list of authors. Actually, my name is Nico Lee, and I'm also from University of Calgary. And unfortunately, my friend and colleague Ahmed and Mostafa cannot be here because of some visa issue. No, it's not dramatic. It's not politics stuff. It's just like maybe some of you can understand. Like you have passport, you have as a foreign student, you have study permit, and you also apply other things. And usually those of things expired at the same time. So Ahmed cannot find a good time window to apply for the UK visa. That's the story. So I'm here presenting the paper for him. I'm not in the author list, so I don't completely understand the entire paper. So maybe at the end I can answer some simple questions. But please feel free to contact with Ahmed directly if you have deeper questions regarding the paper. And which leads to my second apology. Ahmed is an excellent presenter. But sorry, he's not here. You have to suffer from my terrible presentation. Sorry about that. So I know this is the last presentation before the lunch, so I just tried to make it short. And without further ado, let me just dive into this. Interaction history. So we are all really familiar with navigating inside the spatial space. Whether it's 2D or 3D, we have been all trained, like use mouse or a small map, or maybe in the 3D world, like first-person shooter, you just walk through the entire space freely and can always go back to the previous point. We have been trained doing this pretty well. However, when we talk about the temporal access, traverse through the time in an application, software application, this is less explored. We usually get a super simplified version of that. For instance, you probably have seen this action history of like Photoshop, Illustrator, or this kind of software. It's just a simple linear list of actions, one on the top of each other. You can go back to a certain point, but you lose everything beyond that point instantly. So it's more like a dependency list. So in the real world, actually, we're expecting something more like a tree structure. You have the reality paths and maybe some virtual paths, and which allow you to always travel back to a previous point without losing any future content. That would be fantastic. On the other side of the spectrum, this is a case from the game Division. It allows you to go to a certain point and trigger those echoes, which are previous actions in a snapshot. It's really interactive, it's really interesting, but they are all loose coupling. They're all like individual events without a solid structure to connect them together. In the research field, actually, we have already seen something very interesting. For instance, we have already overlapping the virtual content situated on the top of the augmented reality vision. For instance, people can travel back to the history and see the older facade, the older looking of the ancient structure, a building, without losing any the reality. Also, we can go to the snapshot of the previous event and see the details like a smaller window and still have the awareness of the entire situation. And the top one is interesting because this one is slightly different from the Photoshop style history list. This one actually allows you to reverse a history, like a previous action without changing anything in the future. So it's no longer a dependency list. Every single action has been decoupled from others. And we also can see some nonlinear revision, like you can travel back and forth into different branches of the history. However, those like a little bit simple attempts, most of them have been done in 2D surfaces, even though they can exist in a 3D structure, but we're replacing a two-dimensional surface. So surprisingly, actually, in a virtual environment, the interactive history branch is even less explored. Like, it can be a training session in the oil and gas industry, or can be a surgery training. But however, the VR system often fail to leverage the close relation between the time and space interaction in those designs. So to still achieve the same goal, they have to use really linear structure, and people don't have freedom to travel back and forth in the 3D world. You have to follow a linear pattern, a predefined pattern in those tutorials. So this actually leads to the design concept. Can we actually, in a complex virtual environment, for instance, the surgery or training session, can we actually embed a tree structure interactive history branches, allowing people to go back to a certain point in the previous point and still remaining the overall awareness of the entire event, to translate them into a design guideline. We actually first did a sequence of design studies, and then based on that, we convert it into application and further test the possibility of such idea. So the first step is translate the concept into a few design guidelines, which can be used further into a real application. We conduct quite a few different design studies based on Lego bricks or origami. So they are actually simple tasks, but you need to understand the three-dimensional space to accomplish those achievements. So that's the reason we choose Lego bricks and origamis. Like most of the people have been already familiar with those concepts already. So we had 12 participants. They all have even designer or human-computer interaction or visualization background. And we introduced the idea with Microsoft history list or the Photoshop history list. And we asked questionnaires and interviewed them to collect feedbacks. And there are 3 different tasks: building Legos, building origamis based on the instructions, and search for item in a real space. This requires really walking in the interior of the space and looking for different positions. So the basic idea is, in a complicated virtual environment, we probably can have this kind of simplified head-up display somewhere in the interface. And this is more like a graph structure. The node, they are key events you can traverse back to the previous one. And the solid arrows, they construct the reality path. And once you go back to a different node, they will change dynamically. And those dashed arrows, they can be like parallel universes or like a virtual passes, where it's all depend on which node, which sequence of node you have chosen. So based on this simple idea, we had a few different variations to test the idea. This is the basic variation, which is like use the building up a Lego structure, but you can see it's actually bi-directional, right? You can always guide you to travel back, and the virtual part of the history is kind of fading out to give you a visual cue, like which part is the real reality, which part is different alternatives. And another different approach is if we manipulate the transparency or the opacity of the different components in the Lego bricks. For instance, if it's more recent, then it looks more solid. If it's far away in the history, then it's really fading away. So people can really judge the proximity of the events in the temporal axis based on the semi-transparency. Another possible approach is we can use still a linear transparency train. So in the history, it's like fading away. In the more recent events, they are more solid, but we're actually branching them into different paths, right? And the departure angle between the branches actually indicate the distance in the temporal axis in the history, like how far away was that event occurred in history. Then what about play with the individual nodes themselves? Actually, in this case, the nodes, they're animated. They're actually playing small video to refresh memory for the users, which is the adjacent to exactly the moment the node happened, was recorded, so which give the users further visual cues. So we play with all those ideas and talk with 12 participants. And the conclusion is, well, they really, first of all, they really like the idea. They're really embracing the idea. They think this is a really interesting way to, especially in a complicated virtual environment, this can really help people to maintain the temporal awareness on the top of the spatial awareness. When it comes to the design of the visual cue itself, it can be as rich as possible. Animation, as long as it is clear and meaningful, then they actually want, because we have such a high resolution display, they actually really want animations, really want complicated displays in those visualization. However, on the contrary, the interaction needs to be simple. For instance, the transparency, the 2.2 one, actually this one involved with we're asking people to manipulate the view angle of the object, which they need to be drag and drop and try to rotate the object and approach them into a different angle. And they suddenly lose the interest because this is supposed to be a secondary tool for them to understand the temporal behavior. So the main focus should be still at the environment itself, the 3D environment, the virtual environment itself, without having distracted too much into this smaller tool. So they want a enriched visualization, but a really simplified interaction. And further on, it should be a secondary focus in the screen, should not take over the majority of the screen. Based on those findings, and second thing is we try to develop a semi-realistic application using those guidelines, and then conduct a different experiment based on that. So, so the idea is we try to apply this idea into a surgery, a spine surgery, and on the top of that, we use recasting to allow people to select the nodes, even though they are it's in the 3D structure, but we don't want them to play with the depth perception. So they can treat the head-up display as a 2D structure and simply select the nodes by using their gestures. And the thing has been developed in Unity with Oculus Rift. And for the pointing device, we're using a haptic feedback, the touch pen, which can give a precise the position of the pointing, as long as the haptic feedback to the users. And here's a small video. Oops. So when the time progresses, the historical node accumulates itself and advances into different states. The nodes are like snapshots in the history. No matter this is like a real history or it can be a virtual history. You can always jump back and forth in between. And its branches based on users' interaction. Okay. So we also conducted an evaluation based on the application. 6 participants with medical background. And we had a 2-part study. And we use IPQ, which is called iGroup Presence Questionnaires. This is a skill for measuring the sense of the presence of the virtual environment, so the immersivity of the environment. And that's the hypothesis. The study itself consists of the 3 script tasks, a questionnaire, and a post-simulation survey. So actually, the key findings enhance our design guideline. Okay, they think this is really promising, this is really positive. They give us really positive feedback. They really like the idea, the concept. However, they really enjoy the simplified interaction with the dynamic visualization. So this actually enhances our findings in the design study. We want the visualization to be enriched as much as possible while keep the interactions simple. And they also like the idea that they don't need to play with the depth perception. So the recasting idea was a success. And there are some really positive feedback from the SIGCHI students. When it comes to numerical data, this slide reflects that in the IPQ, the aforementioned IPQ questionnaires, all the participants seems to feel present within the immersive simulation, which means they feel, okay, the storytelling is realistic enough. And this chart shows they actually give really high values for spatial and general present in the first 2 bars. And even though when people have previous experience with other simulations, they can still satisfy in our immersive environment. So we think the application itself actually proved the point that the design guideline actually makes sense. And further on, it can be extended into other categories, into other scopes. For instance, what if we replace the virtual environment with an augmented reality environment and allow people to experiment some cooking instructions, right? They can always travel back to a previous point, and if they want to try something different, and we're going to display this head-up display on the top of that, so further assist them to accomplish, like cook a good meal for the family. So in this paper, we present our exploration of how the nonlinear interaction history visualization may benefit the immersive simulation. We also discussed the importance of careful virtual encoding of the history representations based on the aforementioned design guidelines. And we also demonstrated how the interaction history visualization may be integrated within a practical simulation scenario. For instance, in our case, that was the surgery. And we also argue that our ideas are not limited in the previous application and can be extended in other contexts as well. That was it, and thank you very much. And I will try to answer some simple questions, but this is the contact information of Ahmed. Please feel free to talk with him directly if you have more questions regarding the paper. Thank you so much.
Great job, Nico. That was one of the better presentations I've ever seen for somebody who was not an author of the paper. So,
oh, wow. Thank you so much.
Very, very good. So we have time for some questions. I'll bring the microphone. So I have a million questions about this. The first thing the last thing you said actually about AR, I don't see the sensibility of that because it can't like unthrow the salt in the cake. Right.
Right. Yeah.
But every user always wants the undo feature, right? And every developer always groans when trying to implement the undo feature. And I sort of noticed that within yours that it's a very custom build each time for implementing what undo means. I really appreciate the tree structure. And are any applications actually using anything like a tree structure? Because there's in a 3D environment, it's not necessarily different than a 2D environment to implement an undo. And so is there a 2D?
There are some like previous research. Okay, first of all, like reverse the first point of yours. Actually, I totally agree with you. How do we define the undo action is the key, the fundamental point of this kind of experiments. Maybe in the cooking behavior, the real action cannot be undo. You have put something into the pot already, you cannot just take it out, right? But in the instruction, they can give you a different option, like different alternative solutions, approaches of the behavior. Maybe in the instruction, you can always go back, okay, maybe what if I do something in a different way, like what would the result be? So maybe the undo can happen in the instruction, but probably not in the real world. Right. Secondly, the second question, actually in the academic field, there are some experiment in the 2D surface, like animation or drawing, like how to explore with the tree structure. But in the 3D world, surprisingly, it's really like a virgin territory, uncharted territory at the moment. However, we think this is even more crucial because in 2D environment, your cognitive load is not as high as a 3D environment. In a 3D VR environment, people are usually overwhelmed by the structure, the spatial structure. They have to spend a lot of effort in understanding the spatial structure already. And on top of that, we really need to provide them a super easy way to go back into the traverse in the temporal axis. So actually, we think this is more important, but less explored. That makes sense?
Yeah, thank you.
It's very interesting that you picked cooking as an example, where there's indeed actions that you can't quite undo. But virtual reality has all the benefits and none of the drawbacks for this specific reason. So there is no reason not to implement undo because, in fact, you can undo burning the steak in VR, right? It's very easy in VR.
Right, in VR, yes, it is, yeah.
Right? So that actually speaks for strong undo models, and it's actually a challenge because we can do it. There's no excuse, right?
Mm-hmm. Totally agree, yeah, thanks.
Following up on what Wolfgang said, if the scenario though is a training scenario, if you have unlimited undo, it means you'll never try to get better, or you won't have any motivation to become better because you can always undo and go back.
There's a cost to undoing. If you have to undo, it costs you time. That makes you waste time. Thus, you have an incentive for actually doing it better on the first
Good one. Good comeback. Okay.
And besides that, like for a critical environment, for instance, the surgery part, you don't want to undo the real operation, right? That's the reason in a virtual environment, the undo is become even more valuable.
The interactivity with the the tree was really intriguing to me, especially at points where you might want to merge it in, right? So I maybe in certain circumstances it'd be easy to detect that this was actually the same, you got to the same place along a different trajectory.
Exactly.
To then eliminate that path, or maybe keep it around, I don't know, but detecting that would seem to be really hard in a lot of...
To identify whether they are really identical to each other or not.
Right.
So apologize. It's not a really tree structure. It's more like a graph, right?
Yeah.
We allow loops.
Yeah.
We allow more complicated, topology inside this structure. Actually, it's more complicated than a tree structure.
Right. But just detecting that
Yeah.
two are automatically, right? So the user sitting there saving, are they also saying, save to this location in the graph, because this is the same thing, or is the system automatically detecting that these are actually the same?
I think it depends on the situation. Depends on how many parameters you're defining, right? Whether these two conditions they are equal to each other or not. Actually, I have been told in a surgery process, actually, you actually can identify, okay, if these two cases are identical or not, because the procedure is quite, well defined, right? It's possible to use different approaches to achieve the same result. But maybe in other cases, like cooking, it would be more difficult to define, okay, actually they are merging back together. So it's case-by-case study. Yeah.
We have an additional question back here, and then everybody can go to lunch. No pressure.
Ooh.
So as the graph gets longer and longer over time, how's the interaction for you guys to go back to a previous point? Were you selecting and then moving back? How does it look in your interface, right? Because maybe after 5 minutes, the graph has gotten extremely long.
Very great idea. Yeah, point. Yes. At this moment, you will see a super long scroll bar, I guess, in the implementation. So we don't have any existing good approach to solve this problem, but it's definitely possible in the reality. The tree can become not only infinitely long, but huge in two-dimensional space, right? Can be super complicated. I think this is another different territory we can step our toe into. Actually. Thank you so much. Yeah.
All right, let's thank our speaker again.